So these are a little bit semi-complicated, and it's easy if you think of them in simpler terms. You're generally going to compare only numbers on numerators to numbers on denominators, and radicals that are the same. This is a square root, and this is a square root. You're not going to mix them. This first one's pretty simple. They also want you to get rid of any radicals in the denominator. They consider that not simplified if there's a square root in the denominator. But I'm going to show you a couple ways to make this a little simpler on your life. First of all, keep in mind that anything multiplying can sort of be separated out. Sort of be separated out like that. Well, it's clear like 9 divided by 3 is just 3. So we're going to just replace that by 3. Okay. But before we start multiplying top and bottom by square root of 2x, I want you to also realize that when you have, I'll show it to you here with an example. When you have square root of 9 and square root of 81, now we'll reverse it. Square root of 81 and square root of 9, it's pretty easy to realize, okay, well, the square root of 81 is 9, the square root of 9 is 3, 9 divided by 3 is 3. But before you do that, you can also, any radical, you can treat as if the numbers are together. So long as they're both square roots, in other words, nothing there, square root. And I can say, well, 89 divided by 9 is 9. Square root of 9 is 3. So this, you might say, well, why? Because I can just figure this out. Yeah, this is more for when it's not easy to see the square roots. So now we're going to just ignore that 3 that we've already dealt with here. We're going to push this over here. Get rid of everything else. And we're going to pretend that this was all over the same bracket. 8 over 2, right? Well, that's 4. Right? So it's really square root of 8 over 2, which is square root of 4. And square root of 4 is 2. So after this simplifies to 4, square root of 4 is 2. That means I can essentially get rid of the numbers here and here and just put 3 times 2 out here, 6. So far, so good. Now, it's also true you can do it with the x cubed up here over the x. And the rule for this is whenever you're dividing two things with the same base, you can subtract their exponents. 3 minus 1, x squared. What's the square root of x squared? X. So that means the simplified version of this is quite clean, 6x. But I also want you to visually, if you don't understand what I did there, I also want you to visually understand this. We didn't have to rationalize the denominator because it all disappeared. Well, if you want to look at it another way, first of all, let's just put this 3 aside and not worry about it. You can say the square root of 8 here is the same as the square root of 4 times 2, because 8 is 4 times 2, which is the same as square root of 4 times square root of 2, and square root of 4 is 2. So that means square root of 8 is 2 times the square root of 2. Well, that means I can replace the square root of 8 with that. And you don't have to worry about this. Now you can say, okay, well, yeah, up top I have the square root of 2. But also down bottom now, dividing, I've got 3 times 2, which is 6, square root of 2 divided by square root of 2. Well, those cancel. So I'm left with just 3 times 2. For the leftover, 3 times 2 is 6, right? For the leftover here, realize that x cubed is the same as x squared times x. In that case, you would add their exponents, which is the same as the square root of x squared times the square root of x. And the square root of x squared is x. So I got x times the square root of x all over, remember down here, square root of x. And we can see these would cancel. So I'm all left with is 6 times x. So that's another way of looking at it visually if you need to understand it. Personally, I think just learn the rules of power. If the bases match, you're allowed to subtract when they're dividing and add when they're multiplying. Obviously, that's the simplest one. They're going to get a little bit more complicated. This one is annoying because right away, I could say, well, that 3 in the top and that 5 in the bottom do not cancel. Do not cancel. There's nothing I can, the 3 here and there. You're also not allowed to do this because when there's a minus here, this division here applies to both. It's essentially this. 5, 3 times the square, well, let's distribute it first. 3 times the square root of 5 and 3 times the negative square root of 3 is 3 square root of 5 minus 3 times square root of 3. Whenever you have a fraction with a subtraction, they've essentially made it with common denominators. There's 2 roots we can go here. We can realize that this is the same as this. Minus this over the same denominator. This can make our life a little bit easier in that I can see right away these square roots cancel. But it's really not that. Doesn't really help me because the fractions look like terrible mismatches and I'd have to make them common denominator anyway. But my point for this isn't that this is a method we're going to use to cancel. It's to make sure your mind is flexible and you understand fractions. For instance, the reason that's true is, well, 2 over 4, I'm going to subtract 1 over 8. I have to make this 4 8 because I can only subtract when these match. So I have to multiply top and bottom by 2. 2 times 2 is 4. 2 times 4 is 8. So I get 4 over 8, which makes sense because 4 over 8 is a half. Minus 1 over 8. Before I actually just subtract them, it's really this. It's really this. So all I'm trying to do is make your mind realize flexible that, yes, I put it over the common denominator, but you can go backwards to where it started. So 4 minus 1 over 8 is the same as 4 over 8 minus 1 over 8. And then we can say, well, that's the same as a half. So all I'm trying to do is show you that you can be flexible in the fraction. We're not doing that case. In this case, we are distributing it, as we did. So we are going to distribute as we did. And then we're going to say, how do I get rid of that? Well, you might be tempted to say, I'm going to multiply it by the same thing, by 5 over square root of 3. But it's not really necessary. I only need to get rid of the radical 3. But if I'm going to multiply the bottom, I must multiply the top. So 5 times square root of 3 times square root of 3, it's essentially square root of 3 times square root of 3. It becomes 3. And 5 times 3 down below is 15. So that's the bottom. Now at top, essentially put this in brackets. Put it where it is or in front. And we're going to distribute it. The square roots can only multiply square roots, so that's 3 square root of 15. And minus 3, and when square root here multiplies this square root of 3, comes a 3 over 15. Well, 3 square root of 15 minus 3 times 3 is 9 over 15. There's really no way to simplify. Oh no, everything can be divided by 3. So now I could factor a 3 out of both these things. When I factor a 3 out, I have to put brackets, this 3 would disappear. And this 9 would become a 3. And now I can say, well, 3 goes into 15 5 times. And we're done. Yeah, we're pretty much done. That's as simple as I can make it. Square root of 15 minus 3 over 5. This last part's a little tricky. I think technically, instead of distributing the 3, I could have kept it out. So if I keep it out instead in the beginning, if I just work with what I was given, I like to try multiple ways, just in case one path you find easier. Let's not distribute that. And let's instead multiply the bottom by square root of 3, square root of 3. Realize that this is going to become 15. And now I don't have to distribute that 3 yet, because it's 3 square root of 3 times 3. I can cancel out here. And 3 goes into 3 once at the top. 3 goes into 15 5 times. Now I can distribute this. Square root of 15 minus 9 over 5. Whether that's simpler or not, I don't know. Sorry, that's not minus 9. That's minus 3 over 5. Maybe you feel that's easier. Just realize the rule of cancellations are only when things are multiplying can I cancel down below. I'm not allowed to cancel anything like that. You can if they both shared something in common. For instance, I know this is annoying. 27 minus 9. I'd say, well, why didn't I just subtract the numbers? You're right, I could. Over 3. You're allowed to cancel into this one and that one. That's the only time you're allowed to do the rule. So 3 goes into 27 9 times. 3 goes into 9 3 times. 9 minus 3 is 6. This is easily proven if I just do the subtraction. 27 minus 9 is 17. Is it 17? 10, 17, no, 18. And 18 divided by 3 is 6. Yes, you'd say that's easier, but got to keep in mind that that's only because these were subtractable and divisible. You're looking for situations like if these were square root of 9s, it gets a little bit more complicated. The reason this is true is because this fraction is the same as 27 over 3 minus 9 over 3 before we made them common denominator. All right, let's keep going. Simplify. You might say, that can't be simplified. Now, at this stage, you always want to look for numbers that have square roots that can fit in the number inside. For instance, down here, 12 is the same as square root of 4 times square root of 3. Up top, 15 is the square root of 5 times the square root of 3. I can see right away the square root of 3's cancel. And I can see the square root of 4 down here is 2. That's as simple as it gets. Well, why do I see more complicated things up above? Hang on. Oh, yeah, because I only did the first 2. Sorry. It's okay that I skipped around. I don't know which method you might find easier. So always use the method you find easier. We might as well just see what happens when I multiply top and bottom by square root of 3 over square root of 3. Well, I can only multiply the radicals. Square root of 3 times 3 is 3. So I'll get 2 times 3 at the bottom, which is 6. That means this entire thing at the bottom can be replaced with 6. Now, this square root of 3 at the top can be distributed into the brackets. Square root of 3 times 2, square root of 6. Square root of 3 times minus square root of 3, minus 3 over 6. Could that be simplified? I don't think so. Both divisible by 2, but you can't divide the 6 into the square root of 6. There. You can't. You could do something strange. Square root of 6 over 6 minus 3 over 6, which becomes a half. But why? You're just making something no longer over the same denominator. I believe your teacher's looking for that. Okay, so for this one, the lesson is, because the square root of 7 is being subtracted, you cannot just multiply by square root of 7 over square root of 7. It won't work. What you'd get is 7 minus 4 square root of 7 at the bottom. That's no good. So you have to multiply what's called the conjugate. Conjugate is the opposite over the opposite. What's the opposite of square root of 4 minus 4? Well, it's square root of 7, plus 4. Looking at the bottom first, square root of 7 times square root of 7, 7. The middle terms will disappear. Minus 4 times plus 4, minus 16. What's 7 minus 16? It is minus 9. So at the bottom, I'm going to have a minus 9. We don't like minuses at the bottom. Up top, remember that I have to multiply in a distributed form. I get 4 square root of 7 plus 16. Now, to get that minus out from the bottom, I essentially change the signs, or if you want, I have a minus 1 up top, if you want to think of it that way, multiplying the brackets. Or if you want, this minus changes both those signs. So I'm going to get 16. Well, I'm going to get minus 4 square root of 7 minus 16 over 9. Can that be simplified anymore? I don't think so. I don't think so. Sometimes your teacher might also just say like this. He maybe likes to have the 9, and he would just open brackets and just leave things positive. Like that. And then you wouldn't even put the 1, you just have the minus in inside the brackets like that. I don't know what she prefers. I do know it can't be simple. Well, 4. Yeah, but the 4 was already out over here. 4 cannot divide into 9, so I think this is as simple as it gets right there. So we did that first one. What about the second one? Quite easy to see. They kind of made it a bit silly that the top has a square root of 4, and the square root of 4 is just 2. Since this 2 down below is multiplying this thing, they can cancel. But we don't like 1 over square root of 20. So we're going to multiply top and bottom by square root of 20 over square root of 20. On the bottom, it just becomes 20. And 1 times square root of 20 is square root of 20. Note that 1 over square root of 20, when it's rationalized, is square root of 20 over normal 20. Just keep that in mind, because that's how it will be for all time. 1 over square root of 3, when rationalized, becomes square root of 3 over 3. You're going to see this with your exact trig values, where they don't like the square root of 3 at the bottom. Okay, let's keep going. They're all pretty straightforward. Essentially, how do you get the square root out of the bottom? That's what they're going for here. Okay, we'll go with that one first. Since 3 and 4 can't be canceled out, we're just going to start by multiplying top and bottom by square root of 5. Realize that square root of 5 times square root of 5 is 5, times 3 is 15 at the bottom. At the top, you're just going to multiply the square roots, not the numbers. 2 times 5 is 10. Since square root of 10 cannot be simplified, and 4 and 15 cannot be simplified, that's the final answer. Keep in mind that when you see some square roots, you're going to try to find simpler versions. For instance, 32 is square root of 2 times square root of 16. Square root of 16 is 4. So therefore, square root of 32 is 4 times square root of 2. I'm not sure what he's going for here, but I think overall they just don't want the square root at the bottom. So I'm going to multiply top and bottom by square root of 8, but keep in mind to put this always in a bracket. Square root of 8 times square root of 8 is 8, times 2 is 60. Up top, you just multiply the square roots. So I got square root of 18, which, by the way, can be simplified. I'll show you in a second. Square root of 8 times 5 plus 3, square root of 40. Over 16. And you might be tempted to say, okay, well, actually, yeah, it's yeah. No, before I distribute it over here on the left, I think I'm going to say 8. Square root of 8 can be broken down into square root of 2 times the square root of 4. And I'm going to say the square root of 4 is 2. So since it's 2 times this times that, the 2 can divide into this. And it just becomes 8. Then up top, 2 times square root of 3 is square root of 6. Plus 3, 2 times the square root of 5 is square root of 10 over 8. This is a little easier to do it than where I was going. Where I was going would have taken longer. Square root of 24 can be rewritten as 4 times the square root of 6, which is 2 times the square root of 6. And then this could have been rewritten as 3 square root of 40, which can be rewritten as square root of 4 times the square root of 10. Square root of 4 is 2. 2 times this is 6. So you get 6 times the square root of 10. And then you can see that this 2 and these 2, you can take a 2 out of both of them. And you're left with square root of 6 plus 3 square root of 10 over 16. And the 2 goes into the 16 8 times. That's a lot longer root. I would rather cancel it here before I distribute it. And it's harder to see. It's harder to see. Don't have time to do them all. I do want you to note that even when it's square root of 5 or 5 root down here, as long as it's 5 root down below, the rules still apply. Okay, so down below, yeah, I mean, it'd be helpful to think of a way. You know what would be easier? This is an easy solution. Up top, we still have this. Down below, we still have the 3. But 162 is divisible by 2. It's 81. So that's the same as square root 5 root of 2 times the 5 root of 81. And right here, these can cancel. That's easy. So now I have 1 over 3, 5 root of 81. And I'm going to get rid of the 5 root of 81. Top and bottom. Up top, this becomes 5 root of 81. Down below, when these cancel, it's the same rule. No, it's not the same rule, actually. It's now the square of that because it's a 5 root. It doesn't become 81. So up top, I have the 5 root of 81. This is interesting. I think your teacher might have made a small error here. Maybe 5 root has a... 5 root of 81 might have a It's the same as 81 to the power of 1 over 5. Oop. 81 to the power of 1 over 5 is 0.2. No. What's 2 times 2 times 2 times 2 times 2? 4, 8, 16, 32. No, there's no 32 in there. The one thing your teacher did incorrectly here, yes, these cancel, but you cannot just rationalize by multiplying by the 5 root. Doesn't work. This just becomes 5 root squared, which does not cancel out. And I think your teacher doesn't realize that. You'd have to multiply it 5 times. Four times, so that it becomes to the power of 5 and cancels out. So you'd need 4 of them for this to become 81. And then 3 times 81 is 243. And then up here, this would become 5 root of 81 to the power of 4. That's a complicated one. If you want to go over that, we can. That's pretty hard to understand. Essentially, squaring this doesn't get rid of the 5. Multiplying it by 4 of them, 4 more, so that becomes 162, 5 root to the power of 5. When it's to the power of 5, that's when that cancels. That becomes 162. Well, I'd have to multiply it 4 more times, top and bottom. You'd end up with 81, 5 root to the power of 4 up top. And down below, you'd end up with 3 times 81, which is 243. Might even be possible to simplify again, but I don't think so. 32 is the lowest form of 2. By the way, this can be rewritten like this. This fraction. This is the power. This is the root. That's a weird one. I'm surprised you had that. Same with this one. This is 3 root, which means you have to multiply it 3 times. 4 root, you'd have to multiply it 4 times. Maybe you could put it as a fraction, and the fraction would simplify. This would be 2 over 4. Yeah, it wouldn't quite, well, it doesn't quite work. Those are quite interesting and complicated. Not so for this one up here. I'm going to skip that 2 one. It's not that complicated. So this one you would just multiply by the conjugate. Minus 2 plus the square root of 5. And when the bottom multiplies out, it becomes 4 minus 5, which becomes minus 1. And then up top, you'd have to distribute and then like terms and see if it cancels. Well, I guess it wasn't that easy. Let's try it. Okay, to get rid of any bottom, you have to multiply by the conjugate, which is a plus. When it's the opposite sign, the middle term disappears. It becomes 4 minus 5, which is minus 1, which means down below, all I have is minus 1. Up top, you have to distribute like this. 2 times minus 2 minus 4. 2 times square root of 5 plus 2 square root of 5. Minus, minus, so plus 2 square root of 3. Those cannot be added because they're not like terms. And then minus square root of 3 times plus square root of 5 becomes minus square root of 15. All of it over minus 1, which means all the signs up here change based on that minus 1. So you get plus 4. Get rid of this minus 1 down below. Plus 4 minus this. Minus this. Plus that. Can this be simplified? 3? No, not really. Pretty much all there is that can be done. So some more annoying than interesting. Then this is the same idea. We could get rid of the minus first. Would make our life easier. They both become plus. To do so, this would have to become minus. This has a square root, so they're just kind of being idiots here. The square root of this is k to the 2, because k2 squared, k to the power of 2 squared is k to the 4. These can now be added. You get minus 3 over 9, k to the 2. These can be divided, so you get minus up top, and 3k to the power of 2 down below. Since there's no square root down there, it's fine. I don't know if you realize that either. Okay. This one. I think they're making a mistake when they think you can just multiply by the conjugate like that. You can't. You have to multiply twice. This times itself is squared. Down below, when there's 3 of them like that, yeah, it becomes where cube root of 9 to the power 3, which just becomes 9. Down below, yeah, it becomes a 9. This cannot cancel with this 3 because it's being added. We have to distribute. So it becomes 3 cube root of 9 squared plus, these are both cube roots, but that's squared. So it'd be like cube root of 3 times cube root of 9 times cube root of 9. 3 times 9, 27. Times 9 is, so 81 times 3, 283. So that has a 3 root. No, that doesn't. Okay, what is 81 times 3? Sorry, what's 9 times 9 times 3? 243. So you get the 3 root of 243. All of it over 9. And the big question becomes, can I get a 3 out of there? So if I divide that by 3 times 3 times 3 would be 27. So is that divisible by 27? It is. So that is the equivalent of the 3 root of 27 times, what did it end up being? The 3 root of 9. Well, the 3 root of 27 is 3. Since there's a 3 here and a 3 here, I can factor them out. So when I factor it out, it becomes 3. Comes that. The 3 now can cancel to this 9. 3. So I get the square cube root of 9 plus. So the square, so this becomes 1 here and 3 down here. The square of, this is a really complicated one, of cube root of 9 is, well, I'm just going to do it again, is cube root of 9 times cube root of 9 Well, let's rewrite it as this. A square of that is 9 to the 2/3 plus 9 to the 1/3. Which I believe you can add them because it's the same base. No, you can't. It's not multiplying, it's adding. Over 3. Yeah, that's as simplified as it gets. That's kind of a crazy, weird one. Is he trying to make it tricky? That's a bizarre one. So yeah, it's very annoying when you see the 3 root. I don't even know if he knew he was doing that when he did it. If you just thought you could square it. But you can't. So this one, you'd have to multiply it 2 more times to get rid of it. So down below you'd have 3 times 15 x cubed times y. 3 times 15 is 45. Down below you get 45 x cubed y. Up top, you'd have to distribute 15 x to the 3 y squared. Yikes. Yeah, to the cube. Should be able to do this one too. I'm sure this probably simplifies. Made it very nightmarish. And these can't cancel because of this plus up here. I'm going to work on those later. Start the next one with that.